Let's talk about logarithmic differentiation. Now, logarithmic differentiation is a differentiation technique that um, helps us take derivatives of complicated functions. Okay, so how does it work? Well, logarithmic differentiation uses the laws of logarithms. It uses these laws of logarithms to differentiate complicated functions involving products, quotients, or powers, along with implicit differentiation. So there's several steps to logarithmic differentiation. Um, the first step is you want to take natural log of both sides. After that, you want to use the law of logarithms, laws of logarithms, to break up your function as much as possible. Okay. The third thing you want to do is you want to implicitly differentiate both sides of the equation. Um, and then the last thing you want to do is you want to solve for dy dx. And I want to put a little comment in here. Don't forget to substitute y back into the derivative. All right. So let me show you with a simple example. Let's take a look at example 7 together. When you look at example 7, you have a little bit of an issue because you have y equal to x. So you have an x downstairs, but then you also have an x in the power. So we can't use the power rule that we learned in Math 5a. We have to use logarithmic differentiation. So we have our expression y is equal to x to the square root of x. And in step 1, we want to take natural log of both sides. So we do it like this, okay? And in the second step, we want to use the law of logarithms to break it down as much as possible. So in this case, we use the law of logarithms to bring this power down in front. So when we do that, we're going to get natural log of y is equal to x to the 1/2 power times natural log of x. And that completes step 2. Now in step 3, we want to use implicit differentiation to differentiate both sides. When we differentiate the left-hand side over here, we need to use the chain rule. The outside function is natural log, and the inside function is y. So the derivative of the outside function, the derivative of natural log, is 1 over something. We've got to keep the inside function. The inside function is y. And then we've got to multiply by the derivative of the inside function. The derivative of y is just dy dx. To find the derivative of the right-hand side, we see we have a product of two functions. So we have to use the product rule. So when we take the derivative of the first function, we're going to get 1/2 x to the negative 1/2. We got to keep the second function, so that's natural log of x. And then we got to add what we get when we take the derivative of the second function. The derivative of natural log of x is just 1/x. And then we have to keep the first function. So we keep the x to the 1/2 power. All right. In the fourth step, we really want to isolate the dy dx. So to do that, we're going to multiply both sides by y. So after multiplying both sides by y, on the left-hand side, you're going to have dy dx. On the right-hand side, we're going to have 1/2 rad x, natural log of x, plus, when we simplify x to the 1/2 divided by x, that simplifies to x to the negative 1/2. And then we want to take this whole expression and we want to multiply that by y. So the final step we're going to have is we're going to substitute the y back here. So we can simplify a little bit. We're going to have 1/2 rad x natural log of x plus 1/rad x. And then we want to make sure we multiply that whole expression by y, which is x to the rad x. And this gives us our final answer. So I hope you enjoyed this video on logarithmic differentiation. Take care, everyone.